Assalamu alaikum. Let me introduce myself. My name is Munira, and the meaning of my name comes from light, and this is important today. We will talk about a Korean research team. They published scientific paper in January 2022 under the name Enhancement in Photovoltaic Performance of Solar Cell by Electrostatic Adsorption of Dyes on Zinc Oxide Nanorode. My presentation is divided into 5 parts. Zinc oxide nanorods were formed by chemical bath deposition on fluorine top-10 oxide glasses, and the photovoltaic performance of zinc oxide-based dye sensitized solar cell was investigated. A DSSC with 8-hour ground zinc oxide nanorods show a higher power conversion efficiency than devices with 4, 6, and 10-hour ground ones. Further improvement in BCE was achieved in a cell with a sulfur ion deposited zinc oxide FTO electrode. By deposition of sulfur ion on the surface of the 8-hour ground zinc oxide nanorods, the day loading amount increased by approximately 210% compared to that of pristine zinc oxide nanorod. In addition, interfacial resistance at the zinc oxide dye electrolyte. Dye sensitized solar cells are third-generation photovoltaic cells and have several attractive features. They can be semi-flexible, semi-transparent, and low-cost. In addition, they have low fabrication cost, low toxicity, and power conversion efficiencies. We can use some equations to calculate power conversion efficiencies and the full factor of the cell. In this study, an electrostatic method was applied to increase the dye loading amount in a short sensitization time, 20 minutes. The resulting enhancement in photovoltaic performance by electrostatic method and sulfur ions adsorption on surface of zinc oxide nanorods. To grow zinc oxide nanorods and fabricate DSSC, the same materials as those used in reference 25. The FTO glasses cleaned with sonication for 20 minutes, then wash it with di-ionized water and ethanol. Deposit zinc oxide layer and dried. After this process, the glasses was annealed at 300 degrees Celsius for 15 minutes. The FTO glasses with the layer was immersed in aqueous solution of zinc nitrate hexahydrate and hexane methylene tetraamine to form zinc oxide microrods on the FTO substrate. The zinc oxide nanorods on the FTO glasses were annealed at 400 degrees Celsius for 30 minutes. Study morphology and size by scan electron microscope. Absorptiometric analysis to quantify amount of N719 dyes adsorbed on zinc oxide nanorods. Finally, electrochemical studies was done. If you look at this figure, it shows that the zinc oxide thickness increased from 7.5 to 12.8 when they extended to 10 hours, 2-layered zinc oxide nanorods were built. As you can see, the first cell performance with growth time. Increase in the GSC was observed with increasing growth time from 4 to 8 hours. VOC value decreased with growth time. No observed variation in fill factor. And higher value BCE recovered at growth time 8 hours. What is interesting here? At 8 hours, it gives the highest value of BCE. From figure 4 and table 3, we can understand at 20 minutes the BCE have highest value. From next plot, we can understand decreases in the diameter of the semicircle of the sulfur 20 zinc oxide FTO, which indicate that the resistance or impedance decreases. This is clearly shown figure 9, the time-dependent performance variation of the cell, indicating the sulfur ions did not affect the device stability. This study indicates that electrostatic dye adsorption is an effective method to increase the dye loading amount in a short sensitization time, typically 20 minutes. This reduces the formation of zinc ion dye complex, leading to enhanced photovoltaic performance. Some people live in the darkness of poverty and face the greatest dangers of darkness, which is ignorance. Be the photon that free their energy and light their life.